In this series circuit, both bulbs have the same resistance, 6 ohms. And we know that the total PD across them must be the same as the battery voltage, which is 6 volts. Let's just check that with our voltmeter. There we go, 6 volts. If the resistances are the same, then they must share this total PD equally. So each will have a PD of 3 volts across them. Let's just check. Three volts and 3 volts. Good. Watch what happens as I increase the resistance of this bulb here, which I can only really do in practice by changing the bulb, but in our simulation we're allowed to just increase the bulb resistance. So watch what happens to the share of the PD it gets. So as I increase the resistance of the bulb, it takes a bigger and bigger share of the voltage. And you can tell that from the animation as well. You can see that there's lots of energy on this side and hardly or zero energy on this side. So you can see there's a big change in energy in the charges, and that's why the potential difference is very big. Whereas for this one, the charges start, with a lot of energy and end up with, a lot of energy. So that's why the PD across this bit is hardly anything. And if we calculate it, it's going to be 6 minus 4.8, which is 1.2. Let's just see if that's the case. There might be a rounding error. Yeah, 1.2. There we go. We can get the same effect of seeing this bulb getting a bigger and bigger share of the voltage by reducing the resistance of this bulb. Watch what happens to the voltage across this bulb here as I reduce the resistance of the other bulb. See, it continues to get a bigger and bigger and bigger share of the voltage until I can't reduce the resistance anymore. It turns out that the PD is shared in the same proportion as the resistances. So if I make the resistance of this bulb 12 ohms, like this, and I make this resistance 6 ohms, then the ratio of the resistances is 12 to 6, which is 2 to 1. So the ratio of the voltages, the ratio of the PD should be 2 to 1 as well. So here we have 4 volts across this bulb and 1.9 or 2 volts near enough across this bulb. So you get big to small resistance is the same as big to small PD. This ratio of the PDs stays the same regardless of the battery voltage. So if you make the battery voltage 9 volts like this, then the resistances, the ratio of the resistances is still the same, 2 to 1. So you'd expect the ratio of the PDs still to be the same, about 3 to 6. So 6 to 3 is the same as 2 to 1 again. Big resistance to small resistance, big PD to small PD, both 2 to 1. Let's try one last one. We'll set the battery voltage to 10 volts and let's put the bulb resistances as 12 ohms and 3 ohms, like this. So what's the PD across each bulb? Well, again, ignoring rounding errors. So 12 plus 3 is 15. So this bulb here gets 3/15ths of the total PD. And this bulb here gets 12/15ths of the total PD. So 3/15ths is 1/5 and 12/15ths is 4/5. So 1/5 of the 10 volts, that's 2 volts, and 4/5 of the 10 volts makes 8 volts, or 7.9 here. Let's just check then. So it should be 8 volts to 2 volts. So 8 volts-ish and 1.9 or pretty much 2. You could also say that if this is about 8 volts, 10 minus 8 should make 2. Let's see if it's given me 2. Yeah, still 1.9. So about 2 volts. So you see I can combine these two ideas. The first idea is that the PD across this bulb plus the PD across this bulb is equal to the PD across the battery. And then the second idea is that the biggest resistance gets the biggest share of the voltage, and the ratio of the resistances is the same as the ratio of the PDs.